This is a photo of a plate with a large pile of eggs in the foreground and 6 slices of toast in the background. There is a small dish of red jam sitting near the toast on the plate. Figure 10. 1. If you want to test a claim that involves two groups, the types of breakfasts eaten east and west of the Mississippi River, you can use a slightly different technique when conducting a hypothesis test. Credit. Modification of work: scrambled egg, toast and homemade berry jam. No added sugar for breakfast by Chloe Lim/Flickr. CC by 20. Chapter objectives. By the end of this chapter, the student should be able to classify hypothesis tests by type, conduct and interpret hypothesis tests for two population means, population standard deviations known, conduct and interpret hypothesis tests for two population means, population standard deviations unknown, conduct and interpret hypothesis tests for two population proportions, conduct and interpret hypothesis tests for matched or paired samples. Studies often compare two groups. For example, researchers are interested in the effect aspirin has in preventing heart attacks. Over the last few years, newspapers and magazines have reported various aspirin studies involving two groups. Typically, one group is given aspirin and the other group is given a placebo. Then, the heart attack rate is studied over several years. There are other situations that deal with the comparison of two groups. For example, studies compare various diet and exercise programs. Politicians compare the proportion of individuals from different income brackets who might vote for them. Students are interested in whether SAT or GRE preparatory courses really help raise their scores. You have learned to conduct hypothesis tests on single means and single proportions. You will expand upon that in this chapter. You will compare two means or two proportions to each other. The general procedure is still the same, just expanded. To compare two means or two proportions, you work with two groups. The groups are classified either as independent or matched pairs. Independent groups consist of two samples that are independent. That is, sample values selected from one population are not related in any way to sample values selected from the other population. Matched pairs consist of two samples that are dependent. The parameter tested using matched pairs is the population mean. The parameters tested using independent groups are either population means or population proportions. Note this chapter relies on either a calculator or a computer to calculate the degrees of freedom, the test statistics, and p-values. T83 plus and T84 instructions are included as well as the test statistic formulas. When using a T83 plus or T84 calculator, we do not need to separate two population means, independent groups, or population variances unknown into large and small sample sizes. However, most statistical computer software has the ability to differentiate these tests. This chapter deals with the following hypothesis tests. Independent groups, samples are independent, test of two population means. Test of two population proportions. Matched or paired samples, samples are dependent. Test of the population mean of differences of measures for paired individuals or objects. The two independent samples are simple random samples from two distinct populations. For the two distinct populations, if the sample sizes are small, the distributions are important, should be normal. If the sample sizes are large, the distributions are not important, need not be normal. Note the test comparing two independent population means with unknown and possibly unequal population standard deviations is called the Aspin-Welch t-test. The degrees of freedom formula was developed by Aspin-Welch. The comparison of two population means is very common. A difference between the two samples depends on both the means and the standard deviations. Very different means can occur by chance if there is great variation among the individual samples. In order to account for the variation, we take the difference of the sample means, letter 1D44B1, letter 1D44B2, and divide by the standard error in order to standardize the difference. The result is a t-score test statistic. Because we do not know the population standard deviations, we estimate them using the two sample standard deviations from our independent samples. For the hypothesis test, we calculate the estimated standard deviation, or standard error of the difference in sample means, letter 1D44B1, letter 1D44B2. The standard error is letter 1D460, 1, 2, letter 1D45B1 plus, letter 1D460, 2, 2, letter 1D45B2 square. The test statistic t-score is calculated as follows. Letter 1D465, 1, letter 1D465, 2, letter 1D707, 1, letter 1D707, 2, letter 1D460, 1, 2, letter 1D45B, 1 plus, letter 1D460, 2, 2, letter 1D45B, 2 square, where S1 and S2, the sample standard deviations, are estimates of sigma 1 and sigma 2, respectively. Sigma 1 and sigma 2 are the unknown population standard deviations. Letter 1D4651 and letter 1D4652 are the sample means. Mu1 and mu2 are the population means. The number of degrees of freedom, df, requires a somewhat complicated calculation. However, a computer or calculator calculates it easily. The df are not always a whole number. The test statistic calculated previously is approximated by the student's t-distribution with df as follows. Degrees of freedom letter 1D451, letter 1D453 equals letter 1D460, 1, 2, letter 1D45B 1 plus, letter 1D460, 2, 2, letter 1D45B 2, 2, 1, letter 1D45B 1, 1, letter 1D460, 1, 2, letter 1D45B 1, 2 plus, 1, letter 1D45B 2, 1, letter 1D460, 2, 2, letter 1D45B 2, 2, when both sample sizes N1 and N2 are 5 or larger. The student's t approximation is very good. Notice that the sample variances S1, 2, and S2, 2 are not pooled. If the question comes up, do not pool the variances. Note it is not necessary to compute this by hand. A calculator or computer easily computes it. Example 10. One independent groups the average amount of time boys and girls aged 7 to 11 spend playing sports each day is believed to be the same. A study is done and data are collected, resulting in the data in Table 10. 1. Each population has a normal distribution. Sample size average number of hours playing sports per day sample standard deviation girls 920. 866 boys 16321. Table 10. One problem is there a difference in the mean amount of time boys and girls aged 7 to 11 play sports each day. Test at the 5% level of significance. Solution: the population standard deviations are not known. Let G be the subscript for girls and B be the subscript for boys. Then MUG is the population mean for girls and MUB is the population mean for boys. This is a test of two independent groups, two population means. Random variable. Letter 1D44B, letter 1D454, minus letter 1D44B, letter 1D44F, equals difference in the sample mean amount of time girls and boys play sports each day. H0. MUG equals MUB H0. MUB equals ha. MUG not equal to MUB ha. MUB not equal to the words the same tell you H0 has an equals. Since there are no other words to indicate ha, assume it says is different. This is a two-tailed test. Distribution for the test. Use TDF where DF is calculated using the DF formula for independent groups, two population means. Using a calculator, DF is approximately 18. 8462. Do not pool the variances. Calculate the p-value using a student's t-distribution. P-value equals 0. 54 graph. This is a normal distribution curve representing the difference in the average amount of time girls and boys play sports all day. The mean is equal to 0, and the values -1, 2, 0, and 1. Two are labeled on the horizontal axis. Two vertical lines extend from -1, 2, and 1, 2 to the curve. The region to the left of x equals -1, 2, and the region to the right of x equals 1. Two are shaded to represent the p-value. The area of each region is 0. 28. Figure 10.2, letter 1D460, letter 1D454 equals 0. 866, letter 1D460, letter 1D44F equals 1. So, letter 1D465, letter 1D454, letter 1D465, letter 1D44F equals 2, 3. 2 equals 1, 2 half. The p-value is below 1, 2 and half is above 1, 2. Make a decision. Since alpha p-value, reject H0. This means you reject μ equals μ. The means are different. Using the T83, 83 plus 84, 84 plus calculator, press stat. Arrow over to tests and press 4. 2 samp t test. Arrow over to stats and press enter. Arrow down and enter 2 for the first sample mean, 0, 866 for SX1, 9 for N1, 3, 2 for the second sample mean, 1 for SX2, and 16 for N2. Arrow down to μ1. An arrow to does not equal μ2. Press enter. Arrow down to pooled and no. Press enter. Arrow down to calculate and press enter. The p-value is p equals 0.54. The DFS are approximately 18. 8462 and the test statistic is 14. Do the procedure again, but instead of calculate, do draw. Conclusion. At the 5% level of significance, the sample data show there is sufficient evidence to conclude that the mean number of hours that girls and boys aged 7 to 11 play sports per day is different. Mean number of hours boys aged 7 to 11 play sports per day is greater than the mean number of hours played by girls, or the mean number of hours girls aged 7 to 11 play sports per day is greater than the mean number of hours played by boys. Try it 10. 1, 2 samples are shown in table 10. 2. Both have normal distributions. The means for the two populations are thought to be the same. Is there a difference in the means? Test at the 5% level of significance. Sample size, sample mean, sample standard deviation population. A 2551 population B 164712 table 10. 2. Note when the sum of the sample sizes is larger than 30, and 1 plus N2 30, you can use the normal distribution to approximate the student's T. Use the student's T distribution, however, whenever possible. Example 10. 2. A study is done by a community group in 2 neighboring colleges to determine which one graduates students with more math classes. College A samples 11 graduates. Their average is 4 math classes with a standard deviation of 5 math classes. College B samples 9 graduates. Their average is 5 math classes with a standard deviation of 1 math class. The community group believes that a student who graduates from College A has taken more math classes, on the average. Both populations have a normal distribution. Test at a 1% significance level. Answer the following questions. Problem A: is this a test of 2 means or 2 proportions? Solution A: 2 means. Problem B: are the population's standard deviations known or unknown? Solution B: unknown. Problem C: which distribution do you use to perform the test? Solution C: student's T. Problem D: what is the random variable? Solution D. Letter 1D44B, letter 1D434, minus letter 1D44B, letter 1D435. Problem E: what are the null and alternate hypotheses? Write the null and alternate hypotheses in words and in symbols. Solution E: ho. Letter 1D707, letter 1D434 less or equal to letter 1D707, letter 1D435 ha. Letter 1D707, letter 1D434, letter 1D707, letter 1D435. Problem F: is this test right, left, or two-tailed? Solution F. This is a normal distribution curve with mean equal to 0. A vertical line near the tail of the curve to the right of 0 extends from the axis to the curve. The region under the curve to the right of the line is shaded. Figure 10. 3. Write problem G. What is the p-value? Solution G0 1928. Problem H. Do you reject or not reject the null hypothesis? Solution H. Do not reject. Problem I. Conclusion. Solution I. At the 1% level of significance, from the sample data, there is not sufficient evidence to conclude that a student who graduates from College A has taken more math classes, on the average, than a student who graduates from College B. Try it 10. 2. A study is done to determine if Company A retains its workers longer than Company B. Company A samples 15 workers, and their average time with the company is 5 years with a standard deviation of 1-2. Company B samples 20 workers, and their average time with the company is 4-5 years with a standard deviation of 0.8. The populations are normally distributed. Are the population standard deviations known? Conduct an appropriate hypothesis test. At the 5% significance level, what is your conclusion? Example 10. 3. A professor at a large community college wanted to determine whether there is a difference in the means of final exam scores between students who took his statistics course online and the students who took his face-to-face statistics class. He believed that the mean of the final exam scores for the online class would be lower than that of the face-to-face class. Was the professor correct? The randomly selected 30 final exam scores from each group are listed in Table 10. 3. In Table 10, 467, 641, 285, 355, 982, 491, 273, 594, 164, 764, 770, 638, 261, 888, 270, 658, 891, 273, 582, 435, 594, 188, 264, 755, 988, 297, 185, 361, 879, 479, 4. Table 10. 3. Online Class 77, 995, 381, 274, 198, 888, 285, 992, 987, 188, 269, 457, 669, 467, 197, 685, 988, 291, 878, 871, 898, 861, 292, 990, 697, 6195, 383, 592, 989, 4. Table 10. 4. Face-to-face class problem. Is the mean of the final exam scores of the online class lower than the mean of the final exam scores of the face-to-face class? Test at a 5% significance level. Answer the following questions. Is this a test of two means or two proportions? Are the population standard deviations known or unknown? Which distribution do you use to perform the test? What is the random variable? What are the null and alternative hypotheses? Write the null and alternative hypotheses in words and in symbols. Is this test right, left, or two-tailed? What is the p-value? Do you reject or not reject the null hypothesis? At the level of significance from the sample data, there is not sufficient evidence to conclude that. See the conclusion in Example 10.2 and write yours in a similar fashion. Solution 2 means unknown students T letter 1D44B 1 letter 1D44B 2 H0. Mu1 equals mu2 null hypothesis. The means of the final exam scores are equal for the online and face-to-face statistics classes. Mu1 mu2 alternative hypothesis. The mean of the final exam scores of the online class is less than the mean of the final exam scores of the face-to-face class. Left-tailed p-value equals 0. 11. This is a normal distribution curve with mean equal to 0. A vertical line near the tail of the curve to the left of 0 extends from the axis to the curve. The region under the curve to the left of the line is shaded representing p-value equals 0. 11. Figure 10. 4. Reject the null hypothesis. The professor was correct. The evidence shows that the mean of the final exam scores for the online class is lower than that of the face-to-face class. At the 5% level of significance, from the sample data, there is not, sufficient evidence to conclude that the mean of the final exam scores for the online class is less than the mean of final exam scores of the face-to-face class. Using the T83, 83 plus 84, 84 plus calculator, first put the data for each group into two lists, such as L1 and L2. Press Stat. Arrow over to Tests and press 4. 2 SAMP T test. Make sure data is highlighted and press Enter. Arrow down and enter L1 for the first list and L2 for the second list. Arrow down to mu1 and arrow to mu2 less than. Press Enter. Arrow down to Pooled. No, press Enter. Arrow down to Calculate and press Enter. Note: be careful not to mix up the information for Group 1 and Group 2. Try it 10. 2 professors, A and B, teach classes on the same subjects. Scores of 10 students from each class are selected randomly. The final exam scores of the students are as follows. Professor A, 97, 62, 73, 58, 84, 74, 66, 93, 73, 85, Table 10. 5. Professor B, 85, 64, 74, 55, 76, 67, 72, 80, 471, 98, Table 10. 6. Professor A says that the mean score of their class is more than the mean of Professor B's class. Is Professor A correct? Test at a 5% significance level. Answer the following questions. Is this a test of two means or two proportions? Are the population standard deviations known or unknown? Which distribution do you use to perform the test? What is the random variable? What are the null and alternative hypotheses? Write the null and alternative hypotheses in words and in symbols. Is this test right, left, or two-tailed? What is the p-value? Do you reject or not reject the null hypothesis? At the level of significance from the sample data, there is not sufficient evidence to conclude that. Cohen's standards for small, medium, and large effect sizes, Cohen's d, is a measure of effect size based on the differences between two means. Cohen's d, named for United States statistician Jacob Cohen, measures the relative strength of the differences between the means of two populations based on sample data. The calculated value of effect size is then compared to Cohen's standards of small, medium, and large effect sizes. Size of effect D small 0, 2 medium 0, 5 large 0, 8 Table 10. 7. Cohen's standard effect sizes, Cohen's d, is the measure of the difference between two means divided by the pooled standard deviation. Letter 1 D451 equals letter 1 D465 1, letter 1 D465 2, letter 1 D460, letter 1 D45D, letter 1 D45C, letter 1 D45C, letter 1 D459, letter 1 D452. Letter 1 D460, letter 1 D45D, letter 1 D45C, letter 1 D45C, letter 1 D459, letter 1 D452 equals letter 1 D45B 1, letter 1 D460, 21 plus letter 1 D45B 2, 1, letter 1 D460, 22, letter 1 D45B 1 plus letter 1 D45B 2, 2 square. Example 10. 4. Problem: calculate Cohen's d for example 10. 2. Is the size of the effect small, medium, or large? Explain what the size of the effect means for this problem. Solution: mu1 equals 4, s1 equals 1. 5n1 equals 11, mu2 equals 3, 5 s2 equals 1, n2 equals 9d equals 0. 384. The effect is small because 0. 384 is between Cohen's value of 0.2 for small effect size and 0.5 for medium effect size. The size of the differences of the means for the two colleges is small, indicating that there is not a significant difference between them. Try it 10. 4. Calculate Cohen's d for try it 10. 2 is the size of the effect small, medium, or large. Explain what the size of the effect means for this problem. Example 10. 5 problem calculate Cohen's d. For example 10.3 is the size of the effect small, medium, or large. Explain what the size of the effect means for this problem. Solution D equals 0,834. Large, because 0,834 is greater than Cohen's 0,8 for a large effect size. The size of the differences between the means of the final exam scores of online students and students in a face-to-face class is large, indicating a significant difference. Try it 10. 5 weighted alpha is a measure of risk-adjusted performance of stocks over a period of a year. A high positive weighted alpha signifies a stock whose price has risen, while a small positive weighted alpha indicates an unchanged stock price during the time period. Weighted alpha is used to identify companies with strong upward or downward trends. The weighted alpha for the top 30 stocks of banks in the Northeast and in the West, as identified by NASDAQ on May 24, 2013, are listed in Table 10.8 and Table 10.9 respectively. 94, 275, 269, 652, 048, 041, 936, 433, 431, 527, 677, 371, 967, 550, 646, 238, 435, 233, 028, 726, 576, 371, 756, 348, 743, 237, 633, 731, 828, 526, Table 10, 8 Northeast 126, 070, 665, 251, 445, 537, 033, 029, 623, 722, 116, 170, 658, 251, 243, 236, 031, 428, 723, 521, 678, 268, 255, 650, 339, 034, 131, 025, 323, 421, 5 Table 10.9 West. Is there a difference in the weighted alpha of the top 30 stocks of banks in the Northeast and in the West? Test at a 5% significance level. Answer the following questions. Is this a test of two means or two proportions? Are the population standard deviations known or unknown? Which distribution do you use to perform the test? What is the random variable? What are the null and alternative hypotheses? Write the null and alternative hypotheses in words and in symbols. Is this test right, left, or two-tailed? What is the p-value? Do you reject or not reject the null hypothesis? At the level of significance from the sample data, there is not sufficient evidence to conclude that. Calculate Cohen's d and interpret it. Even though this situation is not likely, knowing the population standard deviations is not likely. The following example illustrates hypothesis testing for independent means, known population standard deviations. The sampling distribution for the difference between the means is normal, and both populations must be normal. The random variable is letter 1D44B, 1, letter 1D44B2. The normal distribution has the following format. Normal distribution is letter 1D44B1, letter 1D44B2, tilde letter 1D441, letter 1D70, 71, letter 1D7072, letter 1D70E1, 2, letter 1D45B1 plus, letter 1D70E2, 2, letter 1D45B2 square. The standard deviation is letter 1D70E1, 2, letter 1D45B1 plus, letter 1D70E2, 2, letter 1D45B2 square. The test statistic z-score is letter 1D467 equals letter 1D465, 1, letter 1D465, 2, letter 1D707, 1, letter 1D7072, Letter 1 D70E, 1, 2, letter 1 D45B, 1 plus. Letter 1 D70E, 2, 2, letter 1 D45B, 2 square example 10. 6 independent groups, population standard deviations known. The mean lasting time of 2 competing floor waxes is to be compared. 20 floors are randomly assigned to test each wax. Both populations have a normal distributions. The data are recorded in Table 10. 10. Wax sample mean number of months floor wax lasts population standard deviation 130, 3322. 90. 36 Table 10. 10 problem does the data indicate that wax 1 is more effective than wax 2? Test at a 5% level of significance. Solution: this is a test of 2 independent groups, 2 population means, population standard deviations known. Random variable, letter 1 D44B1, letter 1 D44B2 equals difference in the mean number of months the competing floor waxes last. H0, mu1 less or equal to mu2 ha. Mu1, mu2 the words is more effective says that wax 1 lasts longer than wax 2 on average. Longer is a symbol and goes into ha. Therefore, this is a right-tailed test. Distribution for the test. The population standard deviations are known, so the distribution is normal. Using the formula, the distribution is letter 1 D44B 1 letter 1 D44B 2 tilde letter 1 D441 0 0 33,220 plus 0 36,220 square. Since mu1 less or equal to mu2, then mu1, mu2 less or equal to 0, and the mean for the normal distribution is 0. Calculate the p-value using the normal distribution. P-value equals 0, 1799 graph. This is a normal distribution curve with mean equal to 0. The values 0 and 0. 1 are labeled on the horizontal axis. A vertical line extends from 0, 1 to the curve. The region under the curve to the right of the line is shaded to represent p-value equals 0, 1799. Figure 10. 5 letter 1 D44B1, letter 1 D44B2 equals 329 equals 0, 1. Compare alpha and the p-value. Alpha equals 0.5 and p-value equals 0, 1799. Therefore, alpha p-value. Make a decision. Since alpha p-value do not reject H0. Conclusion. At the 5% level of significance from the sample data, there is not sufficient evidence to conclude that the mean time wax 1 lasts is longer, wax 1 is more effective, than the mean time wax 2 lasts. Using the T83, 83 plus 84, 84 plus calculator, press stat. Arrow over to tests and press 3, 2 samp z test. Arrow over to stats and press enter. Arrow down and enter. 33 for sigma 1, 36 for sigma 2, 3 for the first sample mean, 20 for N1, 29 for the second sample mean, and 20 for N2. Arrow down to mu1 and arrow to mu2. Press enter. Arrow down to calculate and press enter. The p-value is p equals 0, 1799, and the test statistic is 0.9157. Do the procedure again, but instead of calculate, do draw. Try it 10. 6. The means of the number of revolutions per minute of 2 competing engines are to be compared. 30 engines of each type are randomly assigned to be tested. Both populations have normal distributions. Table 10. 11 shows the result. Do the data indicate that engine 2 has higher RPM than engine 1? Test at a 5% level of significance. Engine sample mean number of RPM population, standard deviation 1552, 1660. Table 10. 11 Example 10. 7. An interested citizen wanted to know if Democratic U.S. senators are older than Republican U.S. senators, on average. During a certain year, the mean age of 30 randomly selected Republican senators was 61 years 247 days old, 61. 675 years, with a standard deviation of 10-17 years. The mean age of 30 randomly selected Democratic senators was 61 years 257 days old, 61. 704 years, with a standard deviation of 9.55 years. Problem: do the data indicate that Democratic senators are older than Republican senators on average? Test at a 5% level of significance. Solution: this is a test of two independent groups, two population means. The population standard deviations are unknown, but the sum of the sample sizes is 30 plus 30 equals 60, which is greater than 30, so we can use the normal approximation to the student's distribution. Subscripts: 1. Democratic senators. 2. Republican senators. Random variable. Letter 1D44B1, letter 1D44B2 equals difference in the mean age of Democratic and Republican U.S. senators. H0. Micro 1 less or equal to micro 2 H0. Micro 1 micro 2 less or equal to ha. Micro 1 micro 2 ha. Micro 1 micro 2. The words older than translates as a symbol and goes into ha. Therefore, this is a right-tailed test. Distribution for the test. The distribution is the normal approximation to the student's T for means, independent groups. Using the formula, the distribution is letter 1D44B1, letter 1D44B2, letter 1D4410, 9. 55 230 plus 10. 17. 230 square. Since micro 1 less or equal to micro 2, micro 1, micro 2 less or equal to 0, and the mean for the normal distribution is 0. Calculating the p-value using the normal distribution gives p-value equals 0.4955. Graph. This is a normal distribution curve with mean equal to 0. A vertical line to the right of 0 extends from the axis to the curve. The region under the curve to the right of the line is shaded, representing p-value equals 0.4955. Figure 10. 6. Compare alpha and the p-value. Alpha equals 0.5 and p-value equals 0.4955. Therefore, alpha p-value. Make a decision, since alpha p-value do not reject H0. Conclusion. At the 5% level of significance from the sample data, there is not sufficient evidence to conclude that the mean age of Democratic senators is greater than the mean age of the Republican senators. Try it. 10. 7. The average age of 10 professors selected randomly in University A is 46. 672 with a standard deviation of 8.53. The average age of 10 professors selected randomly in University B is 47. 531 with a standard deviation of 783. Does the data indicate that University A has older professors than University B on average? Test at a 5% level of significance. When conducting a hypothesis test that compares two independent population proportions, the following characteristics should be present. The two independent samples are simple random samples that are independent. The number of successes is at least 5, and the number of failures is at least 5 for each of the samples. Growing literature states that the population must be at least 10 or 20 times the size of the sample. This keeps each population from being oversampled and causing incorrect results. Comparing two proportions, like comparing two means, is common. If two estimated proportions are different, it may be due to a difference in the populations, or it may be due to chance. A hypothesis test can help determine if a difference in the estimated proportions reflects a difference in the population proportions. Like the case of differences in sample means, we construct a sampling distribution for differences in sample proportions. Letter 1D45D equals letter 1D44B, letter 1D434, letter 1D45B, letter 1D434, and letter 1D45D equals letter 1D44B, letter 1D435, letter 1D45B, letter 1D435 are the sample proportions for the two sets of data in question XA and XB. The difference of two proportions follows an approximate normal distribution. Generally, the null hypothesis states that the two proportions are the same. That is, H0, PA equals PB. To conduct the test, we use a pooled proportion, PC. The pooled proportion is calculated as follows. Letter 1d45d letter 1d450 equals letter 1d465 letter 1d434 plus letter 1d465 letter 1d435 letter 1d45b letter 1d434 plus letter 1d45b letter 1d435. The distribution for the differences is letter 1d443 minus letter 1d443 tilde letter 1d4410 letter 1d45d letter 1d450 1 minus letter 1d45d letter 1d450 1 letter 1d45b letter 1d434 plus 1 letter 1d45b letter 1d435. Square the test statistic, z-score, is letter 1d467 equals letter 1d45d minus letter 1d45d minus letter 1d45d letter 1d434 minus letter 1d45d letter 1d435 letter 1d45d letter 1d450 1 minus letter 1d45d letter 1d450 1 letter 1d45b letter 1d434 plus 1 letter 1d45b letter 1d435. Square example 10. 8 problem. 2 types of medication for hives are being tested to determine if there is a difference in the proportions of adult patient reactions. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. Test at a 1% level of significance. Solution. The problem asks for a difference in proportions, making it a test of 2 proportions. Let A and B be the subscripts for medication A and medication B, respectively. Then PA and PB are the desired population proportions. Random variable, PA, PB, equals difference in the proportions of adult patients who did not react after 30 minutes to medication A and to medication B. H0, PA equals PB, PA, PB equals HA. PA not equal to PB, PA, PB not equal to the words is a difference. Tell you the test is two-tailed. Distribution for the test. Since this is a test of 2 binomial population proportions, the distribution is normal. Letter 1d45d letter 1d450 equals letter 1d465 letter 1d434 plus letter 1d465 letter 1d435 letter 1d45b letter 1d434 plus letter 1d45b letter 1d435 equals 20 plus 12,200 plus 200 equals 0. 081 letter 1d45d letter 1d450 equals 0. 92 letter 1d443 letter 1d443 tilde letter 1d4410 0. 080. 92 1200 plus 1200 square PA, PB follows an approximate normal distribution. Calculate the p-value using the normal distribution. P-value equals 0.1404. Estimated proportion for Group A. Letter 1d45d equals letter 1d465, letter 1d434, letter 1d45b, letter 1d434 equals 20,200 equals 0. 1 estimated proportion for Group B. Letter 1d45d equals letter 1d465, letter 1d435, letter 1d45b, letter 1d435 equals 12,200 equals 0. 6 graph. Normal distribution curve of the difference in the percentages of adult patients who don't react to medication A and B after 30 minutes. The mean is equal to 0, and the values 4, 0, and 0, 4 are labeled on the horizontal axis. 2 vertical lines extend from -0, 4 and 0, 4 to the curve, the region to the left of -0, 4 and the region to the right of 0. 4 are each shaded to represent 1/2, p-value equals 0. 702. Figure 10. 7 p equals 0.10. 6 equals 0.4. Half the p-value is below 0.4 and half is above 0. 4. Compare alpha and the p-value. Alpha equals 0.1 and the p-value equals 0. 1404. Alpha p-value. Make a decision. Since alpha p-value, do not reject H0. Conclusion. At a 1% level of significance from the sample data, there is not sufficient evidence to conclude that there is a difference in the proportions of adult patients who did not react after 30 minutes to medication A and medication B. Using the T83, 83 plus 84, 84 plus calculator, press Stat. Arrow over to Tests and press 6. 2 Prop Z test. Arrow down and enter 20 for X1, 200 for N1, 12 for X2, and 200 for N2. Arrow down to P1, and arrow to not equal P2. Press Enter. Arrow down to Calculate and press Enter. The p-value is p equals 0.1404 and the test statistic is 147. Do the procedure again, but instead of calculate, do draw. Try it 10. 82 types of valves are being tested to determine if there is a difference in pressure tolerances. 15 out of a random sample of 100 of valve, a cracked under 4,500 psi. 6 out of a random sample of 100 of valve B cracked under 4,500 psi. Test at a 5% level of significance. Example 10. 9 problem, a research study was conducted about gender differences regarding the use of seat belts in motor vehicles. The researcher believed that the proportion of women not wearing seat belts is less than the proportion of men not wearing seat belts. The data collected represents a random sample of U.S. adults and is summarized in Table 10. 12. Is the proportion of women not wearing seat belts less than the proportion of men not wearing seat belts? Test at a 1% level of significance. Women does not wear seat belts 183, 156 total number, surveyed 2231, 2169 Table 10. 12 solution. This is a test of two population proportions. Let M and F be the subscripts for men and women. Then PM and PF are the desired population proportions. Random variable. PF minus PM equals difference in the proportions of men and women who do not wear seat belts. H0, PF, PM H0, PF, PM equals Ha, PF, PM Ha. PF, PM are the words less than tell you the test is left-tailed. Distribution for the test. Since this is a test of two population proportions, the distribution is normal. Letter 1D45D, letter 1D450 equals letter 1D465, letter 1D439, plus letter 1D465, letter 1D440, letter 1D45B, letter 1D439, plus letter 1D45B, letter 1D440, equals 156 plus 1,830, 2,169, plus 2,231, equals 0. 77, 1 minus letter 1D45D, letter 1D450, equals 0. 923 therefore, letter 1D45D, letter 1D45D, letter 1D4410, 0. 077, 0. 923, 12,169 plus 12,231 square, PEEM follows an approximate normal distribution. Calculate the p-value using the normal distribution. P-value equals 0.1045 estimated proportion for women, 0.719 estimated proportion for men, 0.82 graph. This is a normal distribution curve with mean equal to 0. A vertical line near the tail of the curve to the left of 0 extends from the axis to the curve. The region under the curve to the left of the line is shaded, representing p-value equals 0.1045. Figure 10. 8 decision. Since alpha p-value, do not reject H0 conclusion. At the 1% level of significance from the sample data, There is not sufficient evidence to conclude that the proportion of women not wearing seat belts is less than the proportion of men not wearing seat belts. Try it 10. 9. A survey was conducted about the favorable beverage as tea. The data collected is summarized in the table. Is the proportion of men favoring tea more than women favoring tea? Test at a 1% level of significance. Men-women favor tea 16-18 total, surveyed 230-218 table 10. 13. Using the T83, 83 plus, 84, 84 plus calculator, press stat. Arrow over to tests and press 6. 2. Prop Z test. Arrow down and enter 156 for X1, 2169 for N1, 183 for X2, and 2231 for N2. Arrow down to P1, and arrow to less than P2. Press enter. Arrow down to calculate and press enter. The p-value is p equals 0.1045 and the test statistic is z equals 256. Example 10. 10. Problem. A marketing firm claims that the proportion of younger adults who own electric vehicles is greater than the proportion of older adults who own electric vehicles. A random sample of U.S. adults was taken, and the results of the survey indicate the following. Out of a sample of 232 older adults, aged 35 or older, 5% own electric vehicles. Out of a sample of 1,343 young adults, aged 34 or younger, 10% own electric vehicles. Test at the 5% level of significance. Is the proportion of younger adults greater than the proportion of older adults with respect to owning electric vehicles? Solution: this is a test of two population proportions. Let Y and O be the subscripts for younger adults and older adults, respectively. Then PY and PO are the desired population proportions. Random variable. PI and PO equals difference in the proportions of younger and older adults who own electric vehicles. H0. Letter 1D45D, letter 1D44C equals letter 1D45D, letter 1D442, letter 1D43B0. Letter 1D45D, letter 1D44C, minus letter 1D45D, letter 1D442, equals 0, ha. Letter 1D45D, letter 1D44C, letter 1D45D, letter 1D442, letter 1D43B, letter 1D44A. Letter 1D45D, letter 1D44C, minus letter 1D45D, letter 1D442, 0. The words greater than indicate that the test is right-tailed. Distribution for the test. The distribution is approximately normal. Letter 1D45D, letter 1D450 equals letter 1D465, letter 1D466, plus letter 1D465, letter 1D45C, letter 1D45B, letter 1D466, plus letter 1D45B, letter 1D45C, equals 134 plus 121,343 plus 232 equals 0. 927. 1 minus letter 1D45D, letter 1D450 equals 0. 9073. Therefore, letter 1D45D minus letter 1D45D tilde letter 1D441, 0, 0. 0927, 0. 9073, 11,343 plus 1,232 square. Letter 1D45D minus letter 1D45D follows an approximate normal distribution. Calculate the p-value using the normal distribution. P-value equals 0.77 estimated proportion for group Y, 0.10 estimated proportion for group O, 0.5 graph. This is a normal distribution curve with mean equal to 0. A vertical line near the tail of the curve to the right of 0 extends from the axis to the curve. The region under the curve to the right of the line is shaded, representing p-value equals 0. 4. Figure 10. 9. Decision. Since p-value, reject the H0. Conclusion. At the 5% level of significance from the sample data, there is sufficient evidence to conclude that a larger proportion of younger adults own electric vehicles as compared to older adults. Using the T83, 83 plus 84, 84 plus calculator T83 plus and T84, press Stat. Arrow over to Tests and press 6, 2 Prop Z test. Arrow down and enter 135 for X1, 1343 for N1, 12 for X2 and 232 for N2. Arrow down to P1 and arrow to greater than P2. Press Enter. Arrow down to Calculate and press Enter. The p-value is p equals 0.92 and the test statistic is z equals 233. Try it 10. 10. A government researcher is investigating whether there is a difference in the use of helmets by motorcyclists in different geographic regions for those states where use of helmets is required by law. The research shows that for motorcyclists in the Northeast U.S., 7622 out of 113,230, motorcyclists did not wear helmets. In the Southeast U.S., 7439 out of 104,873 motorcyclists did not wear helmets. Test at a 5% significance level. Answer the following questions. A. Is this a test of two means or two proportions? B. Which distribution do you use to perform the test? C. What is the random variable? D. What are the null and alternative hypotheses? Write the null and alternative hypothesis in symbols. E. Is this test right, left, or two-tailed? F. What is the p-value? G. Do you reject or not reject the null hypothesis? H. At the level of significance from the sample data, there is not sufficient evidence to conclude that. When using a hypothesis test for matched or paired samples, the following characteristics should be present. Simple random sampling is used. Sample sizes are often small. Two measurement samples are drawn from the same pair of individuals or objects. Differences are calculated from the matched or paired samples. The differences form the sample that is used for the hypothesis test. Either the matched pairs have differences that come from a population that is normal, or the number of differences is sufficiently large so that distribution of the sample mean of differences is approximately normal. In a hypothesis test for matched or paired samples, subjects are matched in pairs and differences are calculated. The differences are the data. The population mean for the differences, μ, is then tested using a student's t-test for a single population mean with n 1 degrees of freedom, where n is the number of differences. The test statistic t-score is letter 1 D461 equals letter 1 D465, letter 1 D451 minus letter 1 D707, letter 1 D451. Letter 1 D460, letter 1 D451, letter 1 D45b square root. Example 10. 11. Problem. A study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in Table 10. 14. A lower score indicates less pain. The before value is matched to an after value and the differences are calculated. The differences have a normal distribution. Are the sensory measurements on average lower after hypnotism? Test at a 5% significance level. Subject a BCDEFGA. Before 6, 6, 6, 5, 9, 0, 10, 3, 11, 3, 8, 1, 6, 3, 11, 6. After 6, 8, 2, 4, 7, 4, 8, 5, 8, 1, 6, 1, 3, 4, 2. 0. Table 10, 14. Solution. Corresponding before and after values form matched pairs. Calculate after, before. After data, before data difference. 68660 2. 246 5-4. 1. 749-1. 6. 8510 3-1 8. 8111 3 2. 6181 346 3-2 9. 211 6-9 6. Table 10. 15. The data for the test are the differences 0. 241161832222996. The sample mean and sample standard deviation of the differences are: letter 1D465, letter 1D451 equals 3, 13, and letter 1D460, letter 1D451 equals 2, 91. Verify these values. Let letter 1D70, 7, letter 1D451 be the population mean for the differences. We use the subscript D to denote differences. Random variable, letter 1D44B, letter 1D451, equals the mean difference of the sensory measurements. H0, μ greater or equal to 0. The null hypothesis is 0 or positive, meaning that there is the same or more pain felt after hypnotism. That means the subject shows no improvement. Μ is the population mean of the differences. μ 0. The alternative hypothesis is negative, meaning there is less pain felt after hypnotism. That means the subject shows improvement. The score should be lower after hypnotism, so the difference ought to be negative to indicate improvement. Distribution for the test. The distribution is a student's T with DF equals N, 1 equals 8, 1 equals 7. Use T7. Notice that the test is for a single population mean. Calculate the test statistic and p-value using the student's t-distribution. Test statistic, t, 336, p-value equals 0, 95. Graph, normal distribution curve of the average difference of sensory measurements with values of -313 and 0. A vertical upward line extends from 13 to the curve, and the p-value is indicated in the area to the left of this value. Figure 10, 10. Letter 1D44B, letter 1D451, is the random variable for the differences. The sample mean and sample standard deviation of the differences are: letter 1D465, letter 1D451, equals 313. Letter 1D460, letter 1D451, equals 2, 91. Compare alpha and the p-value. Alpha equals 0.5 and p-value equals 0.95. Alpha p-value. Make a decision. Since alpha p-value reject H0, this means that μ 0 and there is improvement. Conclusion. At a 5% level of significance from the sample data, there is sufficient evidence to conclude that the sensory measurements on average are lower after hypnotism. Hypnotism appears to be effective in reducing pain. Note: for the T83 plus and T84 calculators, you can either calculate the differences ahead of time, after before, and put the differences into a list, or you can put the after data into a first list and the before data into a second list. Then go to a third list and arrow up to the name. Enter first list name, second list name. The calculator will do the subtraction, and you will have the differences in the third list. Using the T83, 83 plus 84, 84 plus calculator. Use your list of differences as the data. Press Stat and arrow over to Tests. Press 2, T-Test. Arrow over to Data and press Enter. Arrow down and enter 0 for letter 1D7070. The name of the list where you put the data and 1 for freak. Arrow down to μ, and arrow over to letter 1D7070. Press Enter. Arrow down to Calculate and press Enter. The p-value is 0.94 and the test statistic is 4. Do these instructions again except arrow to draw instead of calculate. Press Enter. Try it 10.11. A study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for the randomly selected subjects are shown in the table. The differences have a normal distribution. Are the subjects' cholesterol levels lower on average after the diet? Test at the 5% level. Subject obesity EFGHI. Before 209, 210, 205, 190, 8, 216, 217, 238, 240, 222. After 199, 207, 189, 209, 217, 202, 211, 223, 201. Table 10. 16. Example 10, 12. A college softball coach was interested in whether the college's strength development class increased their players' maximum lift in pounds. 4 players participated in the study. The amount of weight they could each lift was recorded before they took the strength development class. After completing the class, the amount of weight they could each lift was again measured. The data are as follows. Weight in pounds, player 1, player 2, player 3, player 4. Amount of weight lifted prior to the class 205, 240, 1 330, 8 368. Amount of weight lifted after the class 295, 252, 330, 360. Table 10. 17. The coach wants to know if the strength development class makes the players stronger, on average. Record the differences data. Calculate the differences by subtracting the amount of weight lifted prior to the class from the weight lifted after completing the class. The data for the differences are 90, 11, minus 8, minus 8. Assume the differences have a normal distribution. Using the differences data, calculate the sample mean and the sample standard deviation. Letter 1 D465, letter 1 D451 equals 21. 3. Letter 1 D460, letter 1 D451 equals 46. 7. Note, the data given here would indicate that the distribution is actually right skewed. The difference 90 may be an extreme outlier. It is pulling the sample mean to be 21.3 positive. The means of the other 3 data values are actually negative. Using the difference data, this becomes a test of a single fill in the blank. Define the random variable, letter 1 D44B, letter 1 D451. Mean difference in the maximum lift per player. The distribution for the hypothesis test is T3. H0, μ less or equal to 0, μ 0. Graph normal distribution curve with values of 0 and 21. 3. A vertical upward line extends from 21, 3 to the curve, and the p-value is indicated in the area to the right of this value. Figure 10. 11. Calculate the p-value. The p-value is 0.2150. Decision. If the level of significance is 5%, the decision is not to reject the null hypothesis, because alpha p-value. What is the conclusion? At a 5% level of significance from the sample data, there is not sufficient evidence to conclude that the strength development class helped to make the players stronger, on average. It should be noted that this data set consists of a very small sample size, with the possibility of an outlier data value. It is important to confirm that the matched pairs have differences that come from a population that is normal. The coach may want to consider increasing the sample size of players in the study. Try at 10, 12. A new prep class was designed to improve SAT test scores. 4 students were selected at random. Their scores on 2 practice exams were recorded, one before the class and one after. The data recorded in Table 10. 18. Are the scores on average higher after the class? Test at a 5% level. SAT score student 1, student 2, student 3, student 4. Score before class 1,840, 1,960, 1,922,150. Score after class 1,922,162, 1,200, 2,100. Table 10. 18. Example 10, 13. 7 8th graders at Kennedy Middle School measured how far they could push the shot put with their dominant writing hand and their weaker, non-writing hand. They thought that they could push equal distances with either hand. The data were collected and recorded in Table 10. 19. Distance in feet. Using student 1, student 2, student 3, student 4, student 5, student 6, student 7. Dominant hand 30, 26, 34, 17, 19, 26, 20. Weaker hand 28, 14, 27, 18, 17, 26, 16. Table 10. 19. Conduct a hypothesis test to determine whether the mean difference in distances between the children's dominant versus weaker hands is significant. Record the differences data. Calculate the differences by subtracting the distances with the weaker hand from the distances with the dominant hand. The data for the differences are 2, 12, 7, 1, 2, 0, 4. The differences have a normal distribution. Using the differences data, calculate the sample mean and the sample standard deviation. Letter 1D465, letter 1D451 equals 371. Letter 1D460, letter 1D451 equals 4. 5. Random variable. Letter 1D44B, letter 1D451 equals mean difference in the distances between the hands. Distribution for the hypothesis test, T6. H0, mute equals 0 ha. Mute not equal to 0. Graph, this is a normal distribution curve with mean equal to 0. Both the right and left tails of the curve are shaded. Each tail represents 1/2, p-value equals 0. 358, figure 10, 12. Calculate the p-value. The p-value is 0.716 using the data directly. Test statistic equals 218, p-value equals 0. 719 using letter 1D465, letter 1D451 equals 3. 71, letter 1D460, letter 1D451 equals 4. 5. Decision, assume alpha equals 0. 5. Since alpha p-value, do not reject H0. Conclusion, at the 5% level of significance from the sample data, there is not sufficient evidence to conclude that there is a difference in the children's weaker and dominant hands to push the shot put. Try it 10, 13. 5 ball players think they can throw the same distance with their dominant hand, throwing and offhand, catching hand. The data were collected and recorded in Table 10. 20. Conduct a hypothesis test to determine whether the mean difference in distances between the dominant and offhand is significant. Test at the 5% level. Player 1, Player 2, Player 3, Player 4, Player 5. Dominant hand 120, 111, 130, 5, 140, 125. Offhand 105, 109, 90, 8, 111, 99. Table 10. 20. Stats Lab. Hypothesis testing for 2 means and 2 proportions. Class time, names, student learning outcomes. The student will select the appropriate distribution to use in each case. The student will conduct hypothesis tests and interpret the results. Supplies. The business section from 2 consecutive days newspapers. 3 small packages of M and MS registered. 5 small packages of Reese's Pieces registered. Increasing stock survey. Look at yesterday's newspaper business section. Conduct a hypothesis test to determine if the proportion of New York Stock Exchange, NYSE, stocks that increased is greater than the proportion of NASDAQ stocks that increased. As randomly as possible, choose 40 NYSE stocks and 32 NASDAQ stocks and complete the following statements. H0. In words, define the random variable. The distribution to use for the test is: calculate the test statistic using your data, draw a graph and label it appropriately, shade the actual level of significance. Graph. This is a blank graph template. The vertical and horizontal axes are unlabeled. Figure 10. 13. Calculate the p-value. Do you reject or not reject the null hypothesis? Why? Write a clear conclusion using a complete sentence. Decreasing stocks survey. Randomly pick 8 stocks from the newspaper. Using 2 consecutive days business sections, test whether the stocks went down on average for the second day. H0. In words, define the random variable. The distribution to use for the test is: calculate the test statistic using your data, draw a graph and label it appropriately, shade the actual level of significance. Graph. This is a blank graph template. The vertical and horizontal axes are unlabeled. Figure 10. 14. Calculate the p-value. Do you reject or not reject the null hypothesis? Why? Write a clear conclusion using a complete sentence. Candy survey. Buy 3 small packages of M and MS and 5 small packages of Reese's Pieces. Same net weight as the M and MS. Test whether or not the mean number of candy pieces per package is the same for the 2 brands. H0. In words, define the random variable. What distribution should be used for this test? Calculate the test statistic using your data. Draw a graph and label it appropriately. Shade the actual level of significance. Graph. This is a blank graph template. The vertical and horizontal axes are unlabeled. Figure 10. 15. Calculate the p-value. Do you reject or not reject the null hypothesis? Why? Write a clear conclusion using a complete sentence. Shoe survey. Test whether women have, on average, more pairs of shoes than men. Include all forms of sneakers, shoes, sandals, and boots. Use your class as the sample. H0. In words, define the random variable. The distribution to use for the test is: calculate the test statistic using your data. Draw a graph and label it appropriately. Shade the actual level of significance. Graph. This is a blank graph template. The vertical and horizontal axes are unlabeled. Figure 10. 16. Calculate the p-value. Do you reject or not reject the null hypothesis? Why? Write a clear conclusion using a complete sentence.